let us discuss this question. If first part says A equals cos alpha sin alpha minus sin alpha cos alpha, okay, then verify that A transpose times A is equal to identity matrix I. Okay, for this matrix A, we are supposed to verify that this holds. How do we verify that? Let's take a look at this matrix. This is question 6 and part first only. So matrix A given A equals this matrix, which is cos alpha sin alpha minus sin alpha cos alpha. Okay, given matrix A is this. Therefore, A transpose, the matrix A transpose would be equal to what? The matrix A transpose would be the transpose of this matrix. This is cos alpha sin alpha over here. The first row becomes the first column, the second row becomes the second column. This is what we have. Therefore, A and A transpose are obtained, and therefore A transpose A, this implies A transpose A would be equal to what? A transpose A would be equal to the product of this and this. This is cos alpha. Let's write the product, minus sin alpha cos alpha times this. This is cos alpha sin alpha minus sin alpha cos alpha. Okay, this is the product, and let's multiply them together. What do we obtain by multiplying them together? Which implies A transpose A is equal to what? Observe carefully. This cos alpha times cos alpha, which is cos square alpha minus sin alpha minus sin alpha. The product would be plus sin square alpha. This becomes cos square alpha plus sin square alpha. Okay. What next over here? This is cos alpha times sin alpha minus sin alpha times cos alpha. Pretty interesting. Cos alpha sin alpha minus sin alpha cos alpha. That will be simply 0. Let me write a 0 over here. This is second row, first column will be sin alpha cos alpha times minus sin alpha, which is sin alpha cos alpha minus cos alpha sin alpha. The overall sum would be 0. Okay. Sin alpha times sin alpha, which will be sin square alpha, and plus cos square alpha. This will be sin square alpha plus cos square alpha. And what is this equal to? Sin square theta plus cos square theta is simply 1. This is 1, 0, 0, 1. This is what I obtained. And yes, this is the identity matrix. This is identity matrix of order 2. This implies that A prime A is equal to A transpose A. The product is equal to identity matrix. And yes, this is what we want to do. Verify. Hence, verified. Right? You may observe that we are asking, the person is asking us to verify this result, because this particular thing is not true in general. This particular thing is true for this matrix, right? For this particular matrix over here, and that's what we have proved. Right. Now this is 6th part 1. Let's see the 6th part 2 after this. What does 6th part 2 say? Let's take a look at this. 6th part 2 says that we are given another matrix A, and then we are supposed to verify, okay, A transpose A is equal to I. We are supposed to verify a similar kind of an expression, similar, exactly same as part 1. So begin with A, okay, given A equals sin alpha cos alpha minus cos alpha sin alpha, and this particular thing implies A transpose would be equal to what? A transpose would be equal to sin alpha. This first row becomes the first column, cos alpha minus cos alpha sin alpha. Okay. Using this, therefore, A transpose A. What is this? This is the LHS of that expression which we have to verify. So let's write A transpose times A. What is this equal to? This is A transpose. This is sin alpha minus cos alpha sin alpha times this here, which is sin alpha cos alpha minus cos alpha sin alpha. Let's multiply them together. What do we get? The product will be another 2 by 2 matrix. What does that look like? The first row gets multiplied with the first column. You multiply sin by sin, we get a sin square alpha. Minus cos alpha, the product would be plus cos square alpha. Okay. Sin alpha times cos alpha is what I obtain over here. Minus cos alpha times sin alpha. Okay, this is the second term over here, right? What next? Cos alpha times sin alpha. And minus sin alpha times cos alpha. This is what I obtain. Right. What next? The second row gets multiplied. The second column, cos alpha times cos alpha is cos square alpha. Sin alpha times sin alpha is plus sin square alpha over here. This is what I obtain. And after reaching this stage, you can observe that sin alpha, cos alpha, this and this get cancelled, this and this get cancelled. This term becomes 0, this term also becomes 0, which gives A prime A, this is A transpose A, is equal to what? This here, sin square theta plus cos square theta is always 1. That's sin square alpha plus cos square alpha is equal to 1. This is 0, this is 0, this is 1. You can observe this is cos square alpha plus sin square alpha, which is also 1. And this implies that A transpose A is equal to identity matrix, and that's what we wanted to verify. Have you verified this? Yes. Take a look at this complete solution once, and that is all in this question.